So let's imagine there's only one ticket left and two buyers click buy at the same time. Order successful. But this is not supposed to be happening because there's only one ticket. So there's no way both of them could have gotten a ticket if there's only one remaining. If you were building this website, how would you stop search from happening? My first instinct will be something like this. Looks perfectly fine, right? Check if the item is available, then reduce the stock. Let's just visualize how that would look like. Both customers saw the last item and both thought it was available and both bought it. Kwa sababu siiko. Customer A checks the stock and then the database responds by saying there's only one item left, almost the exact same moment. Customer B also checks the stock and the database says there's only one item left. Customer A continues to check out and customer B also continues to check out. Customer A updates the stock to 0. Customer B pia updates stock to 0. Both of them succeed. Two customers and both of them have paid for the same item. That's a problem. Where exactly did things go wrong in our code? Because it was perfectly fine. The problem began when we first read the stock. This line over here. Customer A reads the stock and the stock is equal to 1. But before customer A updates anything, customer B sneaks in. So reads stock is equal to 1. Both customers, essentially both requests, believe the item is equal to 1. That is, one item is available. The dangerous part is the tiny gap between reading the stock and updating it. Tiny gap is enough to cause issues in your system. This is called a race condition because both of the requests are racing towards updating the same data, which causes problem. Remember, your code is not running alone. The database might be updating or even receiving thousands and hundreds of requests. So from the database's point of view, this can actually happen. Request A reads the stock as 1. Request B also reads the stock as 1. Request A writes the stock as 0. Both of the requests read the same value. Either of them had finished. And here's what makes this bug dangerous. Application may not crash. And this is not something that will make your system go down. The error is not so obvious. Thing looks successful. Everything looks good because if this request were happening one at a time, this will actually be good code. Your data is wrong. So how do we stop the second request from sneaking in? If we lock the product row. SQL, you can use this line for update. It tells the database one request is currently working with this row. Other requests that are trying to access this row must wait. Now, customer A gets there first. Customer B arrives and waits. What do we mean by locking? Customer A now checks the stock and he sees one item is left. Customer A reduces it to 0, finishes the transaction, and our lock is released. Only now can customer B continue, which means that even if customer B wanted to access this or update that specific row, they will have to wait. There's nothing they can do unless the lock has been released. When they check the stock again for the second time, that is customer B, when they check the stock again for the second time, they will see that there's no item left. Why? Because customer A has already completed the transaction. One customer gets the item and the other one does not. Problem solved, right? Not quite. Because what if we kept that lock when the customer is paying? Let's just think about it. Customer A locks the item, then they start the payment process. 10 seconds pass, 30 seconds, 40 seconds. Maybe the customer needs to enter a PIN, they need to approve payment on their phone, maybe their payment provider is slow, maybe they never finish at all. And during all that time, customer B is waiting, another customer C is waiting, customer D is waiting, customer E is waiting, everyone is waiting. That's bad for business. So the real solution is not locking the product for the entire checkout process. It should exist for one tiny critical moment. It will be like, we start a transaction, lock the product row, then check the stock. If the item is available, reserve it. Then we commit the transaction. And at that moment that you're committing the transaction, the lock is released. And that's it. The lock only existed long enough to safely protect the inventory. Now, payment happens outside the lock. And this part is really important because that means that the payment is done outside, okay? Outside the lock. So the database does not sit there locked waiting for the customer to finish paying. No, the item has already been reserved. The transaction is now finished and the lock is gone. And now the customer can complete payment without blocking everyone else. Let's go over the flow. First of all, we lock, okay? We check, we reserve, we commit, and then we release. What are we releasing? We are releasing the lock and payment. Now you must be thinking, what if payment fails? Simple. The item is returned back to stock. So the item is available for all the other customers. Payment succeeds, we confirm the order. So now let's put the entire journey together. Customer clicks buy, the request reaches your API, API starts a database transaction, and then the product row is locked. The stock is checked, the item is then reserved for customer A, the transaction commits, and then the lock is released. Then payment begins. Okay? Remember, we are only beginning payment after the lock has been released. Okay? So that other customers are not kept waiting. Okay? If payment succeeds, confirm the order. If payment fails, return the item back to stock. And that is the key idea. The lock is only for that tiny moment. Two conflicts could have conflicted the entire process so that you don't keep the other customers waiting. And this is not just another interview question. Companies actually solve these type of problems every single day. One concert ticket, one airline seat, one hotel room, different things. Whenever many people want the same limited thing at the same time, this problem exists. So how can two people buy the same thing at the same time? Because both requests read the same stock before either one of them finished. We stop it, we lock the row, reserve the item inside a short transaction, that Kateni gap we talked about, inside a short transaction, and then we commit, and then we release the lock. Afterwards, we process payment. If payment succeeds, we confirm the order. If payment fails, we return the item. So as you can see, this is not a bug that can crash your system. It's a very tiny thing. And the hardest bugs aren't always the ones that crash your applications. They're the ones that quietly corrupt your data. Data is everything. And sometimes they only appear when two people click buy.